Next speaker is Tobias Lindaaker. Tobias was one of the very first developers at Neo4j. He's been part of most aspects of the development and the technical decisions over the past decade. Most recently, Tobias' development efforts have been focused on the Cypher query language, and in particular on the OpenCypher query project, which he's going to present now.
This should be on. Perfect. I am here because I care deeply about knowledge. And knowledge is derived from insights, and insights come from information, which can be derived from data. So data is really important to us. And that's why I work at Neo Technology, working on Neo4j, because our mantra is help the world make sense of data. And that aligns really well with my personal interests. And with what I want to talk to you about today. So we have, what I want to talk to you about is the query language that we built for querying graph data. So let's first talk about graph data. So we have the data model in Neo4j is something called the property graph model, where nodes represent the objects of your domain. So these are three different entities in a sample graph. Nodes can also have properties. So these gives you the attributes of the objects. So for instance, we have a person with a name, or we have a node here with a name Dan, and another one with a name Anne, and another node of some sort with a brand Volvo, etc. And then they can have labels, so we can know that these two nodes on top are persons, and the node at the bottom is a car. Then, most importantly, we have relationships between these nodes. So the important thing about the graph is how objects in the database are connected to one another. So here we have two people in love, aww, and then they own a car, or one of them owns a car and the other one drives it. Relationships relate to nodes with and has a type and a direction. A relationship always has a direction, but it's up to you. It's up to the domain to make sense of how to interpret that direction. So here, for example, it's important that the loves relationship, that direction is important because Anne doesn't necessarily love Dan just because Dan loves Anne. But in this case, we can see from the relationships that they love one another. But we can also have a relationship lives together where the direction doesn't really matter because it's a reflective relationship. It still has a direction in the model, but we can choose not to care about the direction. And in fact, Neo4j will traverse relationships equally fast in both directions. Then finally, relationships also have properties, so we can add even more value to the properties in our domain. So that's the background on the data model of Neo4j. So let's talk about what I wanted to talk about, Cypher, our query language, the thing that I think can provide you guys with a lot of value. So Cypher is a query language for graph data. It queries graph data by matching patterns. So patterns is the main thing. It's a declarative query language. So you tell the query engine what data to find rather than how to find it. And then the query engine will figure out how to find data that matches that pattern for you. We've designed Cypher to be readable because most queries are read more frequently than are written. They're typically only written once and then read multiple times. So it's useful and important for the query to be readable so you can understand what the hell you've been doing when you go back and read your query again later. And we also wanted a philosophy about Cypher is that simple queries, simple things should be easy to express, and complex things should be possible to express. And we're starting to get there, where really complex things are also actually really doable. We also wanted Cypher to be easy to learn, and for a lot of people working with data, SQL is, and has been for a long time, the ubiquitous language. So we've purposely designed Cypher to be similar to SQL. Wherever it makes sense to be similar to SQL, it's similar to SQL. But then, of course, Cypher is tailored for graphs. So where it doesn't make sense to be similar to SQL, we're, of course, more tailored to graphs. So instead of having tables and joins, we have patterns and pattern matching. And to express these patterns, we use cute ASCII art. So the parentheses here represent nodes, and the hard brackets are information about the relationships. So it kind of looks like a graph, but in text. And this is how we express patterns. So if, for example, we have a query like this, where we have a graph where Stephen reports to Andrew, how would we query that? Well, we write that same thing as an ASCII pattern. So we'll match, that's the keyword for defining, this is the pattern of what I want to match. An employee, that's the label. So these are the two nodes. One representing Stephen and the other representing Andrew. It has the label employee in both cases, and the property saying that this employee is named Stephen, and the other employee is named Andrew. And then we also have the relationship between them, which has the type, the reports to type. Sorry. As I said, Cypher matches patterns. So what are some of the patterns that we can match? The basic, most simple pattern is just nodes with a relationship between them. So this really looks like nodes and relationships. We've got circles representing the nodes and the line representing the relationship. I lied. This is the most simple pattern. It's just a single node. Where we got a label in this case for matching the node. Labels are our way of saying what type of node is this. It's almost like a table in a relational database. And then we also want to match this by property value. We can combine this, have nodes with relationships and more information about that. We can have even longer chains if they fit together. If they don't fit together, if we want to express a triangle of this, we can separate the patterns by a comma. We can even have a pattern that has an unknown length. So this would be repeat the relationship rel type between m and n times. So it's an unknown length. And then finally, we can find the shortest path of something between two known nodes with a certain relationship type in between them. So those are sort of the basic patterns for matching things in Cypher. I said that it's similar to SQL, and here are some of the cases. First of all, and most importantly, I think it's that Cypher has the same mental execution model to SQL, where you work with rows, where you can think of rows of matches. So for each instance of a pattern that's being matched from the graph, you get a row in the mental execution model. We also got filtering. The where clause looks pretty similar to the way it does in SQL. You got aggregation that you know and love from SQL. You got sums and averages, and something that's special for Cypher, I think, which is collect, which transposes the data from rows into a collection, a list of the elements that were collected. And you can transpose that back and take a collection and turn it into rows again by the unwind clause. And you can group things by, like what you would in SQL with group by, except you don't need group by because it's superfluous. So you just use an aggregator, and then the things that are on the same list of things, not within the aggregator in the return clause, for example, are your grouping key. So grouping is implicit. We created Cypher in 2011, so it's got a very young history, and we're working over the years since then to add new features to it and to optimize it. And we think we're at the point now where we can start standardizing. People have been asking us for standardizing Cypher all along. Like, when will you make this a standard? We want to implement this for our database. We want to implement this for our tool that works with graph data. And now we're at the point where we started doing that, and that's the OpenCypher project. We got Cypher, which queries Neo4j today. Neo4j stores graph data. We are turning Cypher into openCypher, which can query any graph data, essentially. Whatever system that stores graph data or deals with graph data, you can use OpenCypher to query that. That's our goal. So we contribute to OpenCypher to the world. It's the standardization of Cypher to be used by database vendors to implement it, tool vendors for supporting Cypher. This is the first thing that we actually already seen happening. We've published the grammar for Cypher, and we've seen tool vendors pick up and implement that for better supporting Cypher, and also, of course, end users using Cypher. We got a website and a GitHub repository where you can find our current process, where we got the grammar, some tests that you can use to ensure compliance if you're implementing your own Cypher implementation, and also the process for improving Cypher. And tomorrow we're hoping to, in the future, we're hoping to also release a reference implementation so that it'll be really easy to get going and implement your own Cypher implementation. This is not just Neo4j. We got several backers of OpenCypher, more or less active. One of the most interesting ones, I think, is Spark. So pretty soon you should be able to query Spark using Cypher. Thank you.